Okay, cool. So as you voted, we're going to look into building serverless APIs using Node.js. And after this, I can share with you the configuration that I have with Circle CI and all the other tools. Can I get a show of hands who's familiar with serverless? So almost half the room. I'm going to go very quickly through the intro so that we don't spend a lot of time on that. But just to start with the story, I want you to think for a second about Twitter. And think about Twitter in terms of scale. So Twitter today has 330 million users. It also creates, we create 6,000 tweets per second. And that adds to 350,000 tweets per minute, which is 200 billion tweets per year. That's a lot of tweets. And if you think of power users like, who can name a power user? Donald Trump, or Obama. They're sending tweets, they're tweeting, and they're basically sending 40,000 tweets to 40 million people or so. So that's a lot of tweets, and that's scale, right? So if we think of Twitter in terms of scale, if we think of their founders, if they had an idea about how much Twitter would have to scale today, they would probably freeze 10 years before, and they would be like, okay, I cannot handle that kind of scale, right? And that's basically me with every single startup idea that I've ever had. I've just had an idea, and then I started talking with people at dinner time. Let's build this. Okay, how many users do we have to support? What kind of platform do we want to support? What programming language is best for scale, and what web server should I be using? And like 4 dinners or maybe 20 dinners after the initial idea, I would just give up. And one of the reasons why I love serverless is it allows me to kind of abstract all of those conversations, because with serverless, I can just write code in the programming language that I like. Most of the times, there's not all programming languages are supported, so my choice is kind of limited there. I don't have to analyze like 20,000 programming languages, so I don't have to spend time on that. But basically, we're going to look into building applications with serverless today, and we're going to focus on building an API using serverless. And the reason why we're building an API is because we already know how to build APIs, right? In Express.js, or maybe in Java or in .NET. We know which are the tools that we need, and we know how to answer most of the questions. But with serverless, because it's a new environment, it's a new framework, we have to kind of relearn, make those small steps, and understand how we build stuff. I've already introduced myself, serverless. What is serverless? For those of you who don't know, they're basically, when we're building serverless applications, we're building applications that either depend on third-party APIs, like, for example, Auth0, which I mentioned earlier, or maybe a database as a service. But we cannot rely only on third-party APIs. We have to run our custom code as well. Most of the time, we have code that's specific to our business. So when we're writing that custom code, we're writing what's called functions as a service. So with serverless, there's 2 bits. The first one is backend as a service, and the second one is function as a service. And we're going to focus mostly on functions as a service today. This is an animation that my colleague Sarah Drasner has created, where she's basically explaining the transition from infrastructure as a service, where we just rented the hardware from a cloud provider or from a provider, and now we get to this tip of the iceberg where we're just pushing our code, and our cloud provider takes care of everything else, like installing the operating system for us, updating the operating system and patching it with maybe security updates, installing the web server for us, managing that. You can imagine attacks like Spectre or Meltdown from last year. With serverless, we didn't have to go update that for anything ourselves. Like other people did that for us. Okay, and then when we're writing serverless code, someone was laughing there. You didn't like that. Yeah, somebody is doing the work for us, but we don't have to do it ourselves. And I think that's the key, one of the key things with serverless, the fact that there's things that we can outsource. As opposed to spending time to patch 10,000 servers, someone is going to do it for us, and someone's going to be paid to do that. Exactly, yeah. So what's your name? Pim. Pim? Pim says that basically when people are updating things for us, they're much faster, and probably we don't even have to know about those security threats because they're going to take care of them for us, and that's very true. Okay, so when we're writing serverless code, we're writing code that reacts to events. And the type of events that we react to are things like an HTTP request, or file has been uploaded in a storage account, or a message has been created on a queue. So we're running code in reaction to a certain event. And what normally happens is our code is stored somewhere in a storage account, and whenever we receive, there's a worker thread there that listens for events for our functions, and whenever we receive a message or an event, that worker is going to figure out whether our code is already running in a container somewhere, or if we have to just take that code that's stored in a storage account and deploy it to a container. And what this normally means is that we have to run that container, and then we have to run the code. And for example, if you have dependencies like NPM packages like MongoDB or I don't know, Java packages that you depend, those have to be installed as well when we're running the container. And this time that we spend getting up the container and installing dependencies is what cold start is. That's something that once you start using serverless technologies, you're going to get more familiar with. And this means that your code can execute immediately if it's already running in a container out there, or it can take up to maybe 20 seconds until your code runs. So depending on the framework that you're using, or depending on the language that you're using, for example, JavaScript, because it has smaller packages, it will be faster. Codestar will be smaller. Or if you're using languages like Java, cold start might be a bit higher. But we're reacting to events. And another important thing is that we don't have to worry about auto-scaling. So the cloud provider is doing that for us. If we have 10 users coming in, we're only going to have 10 servers or 5 servers running with our code. If we have 10 million users, we might end up with a higher bill than we expected, but the cloud provider will make sure that you have enough instances running to serve those 10 million users. And then another key thing about serverless is that we pay as you go. So this means that you only pay for the CPU, the amount of CPU cycles and the memory that you're using while your code is running. If your code is not running, you're not paying anything. What this allows us to do is be faster, so we don't have to focus on things that are related to infrastructure if we don't want to. It also, another key thing that we need to remember is that every function has an execution time limit. That can be either 5 minutes by default, or it can be 10 minutes if you want to do that, and if you have to configure it. So whenever we're building serverless applications, we have to consider the execution time limit. If we have very long running tasks, those are not fit for serverless. If we have very high compute type of tasks, again, they're not fit for serverless. If another thing that we should definitely do is make sure, because of the execution time limit, we have to make sure that our tasks are very granular and well-defined so that they fit into that 5 minutes. They're also stateless. Just like a goldfish that doesn't have any memory. When we're writing functions, we shouldn't rely on state that we're saving on the disk or in memory. Our function can run, the first run can be in this container, and the second run can be in a completely different container, or we shouldn't rely on the state. There's other ways of managing state, so we can do things like put messages on a queue, or we can save state in the database, and whenever a new function kicks off, reads from those data sources. One thing that Mikhail worked on and is new in Azure Functions is durable functions, which basically introduce a stateful kind of workflow where we can save state in between functions by creating this new type of function, which is durable. So from durable function, we can call other functions, and we can save state in between runs. Cold start, I've already mentioned it. But the reason, just to conclude, the reason why we're building serverless applications is because it makes things much easier, and especially it makes deployment so much easier. We're outsourcing things like managing servers to a completely different, to a third party. And serverless is mostly okay, or it's mostly, it's recommended for tasks like image processing, task management, sending notifications. You can imagine things like you have to send 10,000 emails to 10,000 users. You can just start functions that will send those emails, and they're very small tasks that can be executed in parallel, and that's where serverless shines. I mentioned costs. I recommend you check out the serverless calculator. It will give you an estimate of how much maybe your monthly bill will be. You can input here things like how many executions do you think you're going to have, what's the estimated time, and based on that, you can see that, for example, a monthly bill can be $40 or something. The serverless providers are Azure Functions, Amazon Lambda, Google Cloud Functions. I think they're still in beta. Auth0, WebTask. They appeared, WebTask was created because of the need whenever we're doing authentication. Most of the times people had to handle events like signing in or signing out. And basically WebTask appeared because there were so many people running webhooks and having to deploy servers somewhere else to handle those events that they just created their own serverless framework. And then IBM OpenWhisk. Azure Functions and IBM OpenWhisk are both open source. So you can take the runtime from GitHub, run it in your local. You can also see how everything's implemented, and you can contribute just like Mikhail did. Okay, but today we're going to focus on Azure Functions. And the way we're going to approach this talk is answering a series of, I don't know how to do this. I used to know how to do it in a normal environment, in a maybe Express.js type of environment, but how do I do this with serverless? And we're going to answer a series of questions like, how do I create a project? Which are the tools that are available for me? How do I get started? How do I debug and run locally? Some of you that are familiar with serverless will probably know that most of the times in the past we had to use the browser to code, or we had to run things in the browser. So maybe code something locally and then paste that code and run it in the browser. That's not very convenient. How do I install NPM packages? This is a very simple question with a very simple answer, but I had to answer that at some point. I was like, I need a package. Where do I define it? How do I connect to a database? The power of serverless is not only running code, but also running code and connecting to different resources that are out there, like for example, database, queue, blob. Where do I save environment variables? Whenever we're developing in our local or whenever we're in the cloud, we need environment variables. How do we read data from Cosmos DB? And then, because we're looking at an API, how do we create REST-like URLs? How do we configure that? And how do we deploy to the cloud? We've done all this work in our local. How do we actually push things to the cloud? What are we building? We have this page with cute puppies where we can create new puppies. We can also edit puppies and delete puppies. Nobody wants to delete puppies, obviously. But it just shows the CRUD type of operation and the types of endpoints that we want to create. Okay, how do I create a project? And this is where I'm going to use, to go directly to my IDE. But before that, I actually want to mention a few things. So there's different options depending on the type of person that you are. Think very deeply, who am I? So if you're an IDE type of person, you can use VS Code, which is multi-platform, or if you're using a Windows machine, you can use Visual Studio to get started with Azure Functions. You can also use the browser to run your functions, to code your function, to debug, well, to print things and see the logs for that. And you can also test your functions in the browser. I'd argue that that's not ideal, but that's out there to get started very quickly. Also, you can create functions and get started using a CLI, the Azure Functions CLI. And one thing that I want to mention is that Azure Functions has two different versions. So the initial version, the version 1, was built on top of .NET Framework, which is very, it was running only on Windows. And last year, .NET Core has been released, which has been open sourced, and it's also available on different platforms. So as you can see, I'm using a Mac. I couldn't possibly be running version 1 of Functions because it wouldn't be running on my machine. So my favorite tool from this list is VS Code, but you can use Visual Studio as well if you want to. And I'm going to go ahead and open VS Code. And let me know if you're seeing okay the text. So this is VS Code, and there's this Azure panel here where I have a few extensions installed. So one of them is Azure Functions. You can get it from the Visual Studio Marketplace if you want to. And here I can do things like see the list of functions that I've already created, but I can also create a new function app, which is grouping for all the functions that I want to create together. I can also create new functions, and I can publish, deploy my function app to the cloud. So already with the extension, and one of the things that I'm always saying is that the Azure Functions extension to VS Code is the best thing that has happened to Azure Functions because it makes things so much easier. So we're going to go ahead and create a new function app in my current folder. And in the version 2 of Azure Functions, which is still in preview, there's only 3 languages supported in my local, JavaScript, C#, and Java. But if you use the browser, you can actually enable experimental languages, and you can use languages like Python or I think PowerShell. There's other languages that can be used. But I'm going to choose JavaScript. And then that's it. It generated a function app, which allows me to group different functions. And in the VS Code folder, I have the configuration for debugging functions. And then in host.json, I can define global settings for my functions. Things like if I want to use API type of URL, a certain URL, I can define it here. And then in local.settings.json, this is where I define my environment variables. So you can see already that there's this Azure Web Storage value key, actually, that doesn't have a value, but we can populate it there. Okay, so then I said that this is just like a folder where we create new functions, multiple functions. So I can go ahead and click plus and create a new function in the same folder. And here I can choose different types of event that I want to listen to. The first one is the HTTP trigger. So here I would be creating a function that reacts to a HTTP request. I can also create functions that react to a new file that has been uploaded in storage. So here you can imagine a CSV that has been uploaded and we have to process it. We run a code that processes that function and then we save data into a database. Queue trigger, same type of story. A new message is created. Let's run some code and do something else. Or a timer trigger, which can be like a cron type of job. So we can use a timer trigger to run code every day or every month. There's people that have created functions to let them know that they have to pay their bills. Not me. That was such a bad joke. So I'm gonna create a function that's named get puppies to make up for bad jokes. And you can access this URL for this function. There's different security levels, so you can access it from an anonymous perspective, which means that the URL is available for everyone. Function means that there's always going to be a code. So whoever calls the function has to have that code. And then admin, Miguel, what does that do? I don't think anyone could cares about admin. So I'm going to create an anonymous function. And what this has done for me is it has created this folder that has the same name as the function that I've just created. And then there's 3 new files generated. The first one is the function.json file, which is basically a file that contains the configuration for our function. It's a JSON file, and we define a list of bindings, which you're going to understand very soon. And here you can see the options that we've selected. So the authentication level of our function is anonymous. The type of our function is a HTTP trigger. The direction is input, which means that we're reading for an HTTP from an HTTP request. And the name of the parameter that we're reading from is rec, from request. And then we also have an output binding, which is an object that we're writing to. And this is of type HTTP as well. Output, so out is for output, and the name is res from a response. The other file that gets generated is index.js, and I'm gonna put these side by side. So you can see in my index.js that this is a JavaScript function that receives 2 parameters. The context object, which we're using to communicate with the function's runtime. So with the context object, we can set the response object, we can read from the bindings object, we can log data, and we can also call a method called done. And this will tell the runtime that our function has finished executing. We don't have access to the node processes because this is the cloud provider's job. And that's why context object is just a wrapper around what we can do with the runtime. So the code here, and what I wanted to show by putting them side by side is we have the rec coming in as a parameter, and we have defined rec in function.json. And we're setting the response object on the context, and res is defined in function.json as an output binding. And what we're doing in this function is we're logging that the function has started processing, and then we are checking whether our request object contains a query parameter named name, or it contains a body, and it has a name field inside the body. And if that's true, we're just going to reply hello with the name that has been passed in. Otherwise, we are just replying we are sending an error saying that you have to pass in a name. And the status here is 400. In the other case, by default, it's 200, which is success. Okay, cool. So we've generated our first function. And what we can do now is, yes?
Is there some magic going on that recognizes your function definition and says, I see that two times? Or is it in order?
So for there should be, that's a very good question. Context, I know that you can name it however you want, and then the rec, you can also get it from binding. So if you get it from context.bindings.rec, that will be the object that it will retrieve from the function.json. But in this case, rec, it will be just for order, for the order of the parameters. Very good question. You get a t-shirt. Okay, cool. So to run this function, we just had to go in VS Code to this icon, which has a small bug, and then click run. And because we already had in our VS Code folder, we had the debug configuration, we didn't have to do anything. And we can see in the terminal that our function runtime has started. So this, when we clicked run, this is the command that has been ran in our CLI, func host start. And we can see here things like, I think at some point they were also listing the runtime version that we're using in our local, so we can match that with what's in the cloud. But one thing that has been generated for us is the URL that we can use to call this function. So I can click command or control and then click, and this will run my function. So I can see that there's an error, which we already expected, right? Because we didn't pass in a name parameter. So I can go ahead and say name equals, sorry, sudo. And I'll get hello sudo. Sudo is Sarah's puppy. What's your puppy's name, Burke? Grover. That's a funky name. Let's say hi to Grover. But before we do that, let's add a breakpoint. So I can go add a breakpoint before we run the if statement. And I change the name. So when I run my function, it just enters in my breakpoint. And then I can inspect things like the request or the context, see the list of bindings, and we can see here that I have the rec object available, and it has things like which are the headers, the type of method that we're running, and the parameters, the query name, just seeing it there or here. So maybe this looks very simple to you here, but if you've written code in the browser to run serverless, then you know how powerful this is, because now we can run and debug code. We can connect to resources in the cloud. We're going to see this in a bit. And we can do that from our local, so we can test our code and then just push it to the cloud. Okay, so I've said that we're going to create endpoints, but so far we've only done a hello world function, right? Which is not great. Okay, so I'm going to close the function runtime there. And now, instead of just writing all the code myself, I have used a thing called VS Code Snippets. Are you familiar with that? Yeah? And I've just written a lot of code to read data from Cosmos DB. And we're going to walk through this. So the first thing that we're doing here is we are requiring the MongoDB NPM package. And already there's a boom. We mentioned that we have to know how to install NPM packages. And the answer is going to be super simple. We have to just create a package.json file in the root of our function app. Another reason why I'm mentioning this is because previously we had to include a package.json file for each function, and that meant that we spent time installing packages for each function, which meant that cold start was going to take longer. And now we want to be able to share those packages between functions, so we can just go ahead and create a package.json file. And I have a helper here where I'm just requesting the MongoDB package. Okay. And I can run npm install here. And this is going to install packages for my function so that I can run it in my local. When we're going to deploy into the cloud, those packages can be just copied in Azure, or depending on the type of deployment that we're making. For example, if we're just deploying from GitHub, then the runtime will know that it has to install npm packages. Okay, so we have a dependency. We have installed our dependencies, and if we go back to our code, I have here an authentication object that I use to connect to the MongoDB package. So I'm exposing here all of my secrets. The user that I use to connect to Cosmos DB, the password, the key that I can get from the Cosmos DB database from the portal, and then I'm also connecting to the URL of the database, and then basically I'm writing code that would be very familiar to everyone here, where I'm just connecting to a database called admin. So I've connected using the Mongo client. I've connected to the database, and then I'm selecting the admin database. I'm reading from the Puppies collection and calling find and converting that to array. And in theory, that should give me a list of puppies that I have stored in Cosmos DB in Azure. And then I'm closing the database, setting the response to the result and then calling done. But as I mentioned, I'm exposing all my secrets. If I were to push this code to GitHub, people wouldn't be very happy, or they would be super happy because they have access to my database. So ideally, I want to move these credentials to environments. And I can do that in Azure Functions. I can save them locally in local.settings.json. And instead of spending time copying from one file to another, I'm just going to use this helper file, and I'm going to paste the values that you've seen earlier. So I've saved them in my local.settings, and then if I go back to the function file, instead of using this hard-coded value, I can just access process.env, and then this should be Cosmos user, maybe Cosmos DB user. Let me check that. Yeah. Okay, and then instead of using password, the actual password, I'm going to use process.env.cosmosdb PaaS. Okay, that's correct. And then I have to use the URL instead of the hard-coded one. So the runtime will know to go read those variables from the local.settings.json file. And if things are okay, we should be able to run our function. So we've defined local.settings.json. We have installed the MongoDB package. So I should be able to run this function. Am I missing anything? And it's going to give me the URL again. So if I just refresh this, we no longer need the name. We have retrieved the bestest puppy. And the bestest puppy is available in this Cosmos DB database, which is called Serverless Puppy, I think. So then the next steps would be to define a create endpoint, which would be exactly the same, but I would have to, instead of calling find in the Mongo client, I would call insert one, and so on and so on. Another thing that I mentioned that we have to do when we create an API is define a certain type of route, right? So this means that we want to define things like puppy slash, well, in this case it would be puppies, but then if we want to update a puppy, we'd have to be able to pass in an ID or an actual object. And the way we can define different routes in Azure Functions is go back to the function.json file, and we can define here a route and say that we want to name this route puppies, and this will overwrite the name that we have defined earlier. And we can also listen to only a certain type of method. So here we would want to be able to listen only to the get method. And we can test this now. So if I just go back to this URL, I should be able to retrieve the same data. And now get puppies shouldn't be available anymore. It's not available because I've defined a new path. Okay, so we haven't created all the 4 endpoints, but I hope that's okay. I would just have to again use the snippets. It wouldn't be very valuable. We have installed npm packages. We have changed the route for our endpoint. The next thing that we want to be able to do is deploy our function to the cloud, right? And I mentioned before that just going back to the Azure panel, I can publish a function. So I can click the arrow and line icon and just select a few items like which is the subscription, so what subscription am I using to pay for this function that's running, and then I can either create a new function app in the cloud or I can deploy to an existing one. So I have all these functions that I've created previously. I can create a new one. So I'm going to create a new one. And let's name this Codestar. How's that? It was correct spelling, right? So one thing with the name of the function app is that it's unique, and it's unique for the whole world. So I think that someone else in this world has created a Codestar. Codestar NL. Okay, that worked. And then I can create a new resource group. That's again just like a logical grouping for my functions, but not only for my functions. You can imagine that we're defining a database in the same resource group, and we're defining a storage account in the same resource group. And whenever we want to delete these resources, we just have to delete the resource group, and it will manage all the resources inside that. Okay. For the storage account, we're going to create a new one as well. This is going to take longer than reusing one, but just wanted to walk you through all the steps. So then here we can see in the logs what's happening in the background. one thing that's happening when we're publishing from VS Code is that our code that we've written is going to be packaged together and then pushed to the cloud. That means that we're also packaging our node modules, which makes it, for example, if you're using native modules in your function, you'd rather want to install those modules from the cloud, not package them, because I'm running on a Mac and then my function is going to be deployed either on a Linux machine or a Windows machine, so the native modules are not going to be matched. Do you have any questions? No? Are you excited to see the result? One thing, so now it's going to tell me that in my local I've used the beta runtime, and do I want to update the remote runtime to use beta as well? I'm going to say yes. Once my function app is created here, I'm going to be able to see it in the list of functions that is here. So you can see that it's deploying already. And some other things that I'm going to be able to do from this extension, I could add new application settings right here from my IDE. And you can do this not only for functions, but if you're using Azure for maybe app service, you can do this from this extension as well. So I can just right-click and add new setting. I can also stream logs, so I can see the logs from the function that's running in the cloud in my VS Code, and that's great as well because there's fewer run trips to the portal to see different things. So we're almost there. We have finished successfully. If I go back to the portal, it's going to give me the URL of the function here, but you can see that it still has get puppies. So actually, if I want to run the function, I want to use the puppies route that we've just defined. And it's going to take a bit because of the cold start, because now we have just deployed our function. So it's going to take a while to see that data. But I can go into, probably it's not up yet completely. I can go in Postman, and we can see, I think I was too eager to see results. Oh, what am I missing? We're missing our environment variables. That's correct, because we have set them in our local, but we didn't set them, so it's normal that we get a 500. So I can go ahead and add them from VS Code, and I can copy them from here. So Cosmos DB URL, and then this is the URL. Okay. And then I can show you also how tedious, no, I shouldn't be using this word. But if I go to the portal, I have to wait for everything to load. I have to go to the functions tab. I have to select the function that I've just created, so search for it. Codestar NL. And then from here, I can see the application settings, so I can also create new settings here. But because I've just written my code in my IDE, I much rather add app settings there. So this is how I would add a new app setting in the cloud, in the portal. And I'm going to do that quickly. Okay. So then I'm saving this. And then if I go back to this view, probably once this is saved, I can see them in this view as well. So let's see again if this works. So it's going to take a bit longer for the first run. But yeah, it works. Woohoo, 200. So it took 11 seconds, almost 12 seconds for the first run. But then if I run this again, this will take only 1 second and 1 second. Sometimes it's faster. The database is in the US, so probably that's one of the reasons why it's slower. Okay, we've done a lot of things here. Have you seen this, this portal before, some of you? No? Okay. So this is where you can see the functions, and this is where you had to write code in the past. This will list the functions that we've created. And here we would see the code. We can edit the code that we've written here, but also view the files that have been uploaded and test the function right here in the portal. So I can go ahead and just click run, and this will show me the logs as the function is running as well. And the output here. So just to kind of get an overview of how it looks like in the browser, and then VS Code plus Postman, you choose what feels best. Okay, I think I'll have to wrap up. One of the things that I wanted to mention is bindings. So how do we connect to Cosmos DB? We've already seen bindings in function.json. Those were only HTTP triggers, but actually with Azure Functions, you can connect to different data sources and read from them, and you can also write. So that's input bindings and output bindings. And there's different types of bindings. So the blob one is a binding, Cosmos DB can be a binding, and also Q. There's other services in Azure, and you can create your custom bindings as well. For Cosmos DB, it's in version 2, it's an external extension which you have to install by running a func extensions install, which is the CLI. And then in order to define it, you just have to add a new entry in function.json, which is this one. And we're defining the type of binding as Cosmos DB, which is the name of the object that we're going to use in bindings. The database, the collection name, the SQL query that we want to run, and the connection string. And then we define the connection string in local.settings. And then to use it, it's only one line of code. So we're just accessing that object. Whenever we're creating a binding, when our function starts, the SQL query that we mentioned is going to run, and it's going to return all the results in this new object that has been defined called all puppies. And I think this is super powerful. This is really great because you don't have to write a lot of code, and it gives you a lot of power with just very small effort. Okay, we've seen how we do REST URLs. We've seen how we deploy. So we've answered questions like how do we create projects, how do we run and debug locally? We use VS Code and Azure Functions. In the Azure Functions extension, how do we install npm package? We know this already. We just use a package.json and we run npm install. How do we connect to a database? We use the npm package MongoDB. We can also use the extension. How do we save environment variables? We use the local settings.json in our local, and then there's up settings in the cloud. How do we read data from Cosmos DB? We can use the binding, and that's super simple. And then how do we configure REST-like URLs? One thing that I didn't mention was that we can use also proxies. So the setting that we've seen was just for that function, but then if we want to create multiple function apps and serve them under the same domain, we can do that using proxies. And how do we deploy? Using the Azure Functions extension, but we can also use GitHub we can connect, we can set up a CI/CD process using GitHub and Azure Functions from the portal. A list of resources that I'm going to share with you when I'm sharing my slides for learning more about Azure Functions and all the triggers and all the extensions. Thank you.
Thank you very much. Are there any questions? Oh, many questions. Very good.
Hi, yes, thanks. I'm curious, when would you use Docker containerized deployments over serverless deployments? And in your opinion, what is that choice between the two? Because you got a lot of flexibility with a container, and you got a lot of, it seems like, speed because of all this infrastructure on that side.
Yeah, so with Docker, you will have to manage the Docker instance, and you will have to make sure that, for example, the operating system that you're using, the image that you're using, is going to be up to date with the latest patches and the latest updates. With Docker, you have a lot more flexibility in terms of compute, right? You don't have this limitation for 5 minutes or 10 minutes for execution. You can run as much as you want. You can install whatever software you want on Docker, but it's almost like you're creating your own machine container, and you have to manage it still. You have to plan for auto scale. You have to plan for all the things that you had to when using platform as a service. And with Docker, you still pay for how long for a monthly bill, for example. If you're using, if you're not using things like Kubeless, which Kubeless is Docker inside, it's serverless with Docker. But not everyone is very on board with that, but you can do it. You still have to manage the operating system and the server. So that would be, so if you're looking for short running tasks that can run in parallel, that auto scale, and they cost very little, you can use serverless. If you're looking for higher compute, more demand in terms of compute, long running tasks, you'd better off using Docker. Does that answer? Yeah.
Hi. I was wondering, with these, you can have multiple functions, and like you were working on one right now, but if you have multiple, is there a way to share code, like have a common base in that?
Yeah. So you can, for example, in Node, you can just export you can create a JavaScript file, you can export functions and import them in a function. With .NET or with TypeScript, because you can write functions in TypeScript as well. You can import classes. I have some examples in some of my GitHub repos with how to share code and how to write tests for serverless, for functions.
Any more questions? Not really. Okay, well, before we go, you have some stuff for us also, I think.
Yes.
So I think, yeah, just tell you.
I do have, so this is a lunchbox, if you have kids. And
Or if you just like want to have a lunchbox, of course.
Carp Cloud, and then I have some t-shirts here with Carpet Cloud as well.
Thank you.
So and I have stickers that are very similar. Some of them are just what you saw in the, like even, I don't have this one printed, but I have a few stickers with the bit that I mentioned earlier. And
well,
yeah,
we'll put it here. Well, it's very cool, and you have an Esprino here, so something for you actually. Yeah, also cool to check it out after when we get drinks afterwards, and also we have some small gifts for you.
Yay! Thank you.
Thank you very much. One more time.
Thank you for having me.